Welcome to today's class. This is actually a guideline. Myself, Taheruzzaman. I'm going to give you a guideline in a practical based, which one recently I developed for a project. How many numbers of parallel string can be implemented in a PV farm? So, first of all, very first segment, I would like to give a brief description of maximum number of parallel string based on inverter and short circuit current rating of a PV module. Four fundamental phenomena we have to observe. First of all, the inverter maximum DC current. Afterward, inverter maximum short circuit current rating and PV module short circuit current, commonly short ISC, and obviously the safety factor based on NEC or IEC, whatsoever your country is following, you have to follow that regulation. Afterward, the very important phenomenon is to we have some data, right? So whatever we are going to design, we should have some module or data. Indeed, let's start PV module datasheet. So we should have a PV module datasheet. And obviously, throughout my guideline, today's guideline, I'm going to provide you some datasheet as well in a practical based. So first of all, we have to have a PV module datasheet. PV module datasheet where we actually have the short circuit current of the module. And for inverter, what we have the maximum DC current, and this maximum DC current is equals to nothing but the maximum DC input current, and unit will be ampere. And another data from the inverter, that is short circuit maximum current, which is actually the maximum allowed PV array short circuit, and of course the unit will be ampere as well. And the point we discussed that the safety factor, right? So the safety factor, let's say 1.25, and which is actually the worst case scenario of irradiation, and this 1.25 have taken actually the NEC standard and IEC standard as well. And now another important point, remember whatever I'm going to write down this thing, this is actually a step by step solution or a step by step guideline. So now uh, if we consider this first 3 point, this is let's say point number 1. So this is point number 1. Under this point number 1, again I'm going to give a summary, that is PV module, then inverter, and the safety factor based on the guideline given by your country, which one uh, following. Like in Bangladesh, SREDA is important, they are giving some guideline. PDV also given some guideline. And also power cell also given some guideline. And of course the international organizations like ISO, NEC, they also given some guideline, and we are going actually to follow to design some PV farm. Anyways, now number two, that is actually short circuit current per string. Per string. Indeed, the short circuit current of string is equals to the short circuit current of module. This is very important, that the string short circuit current and the module short circuit current is equal. And the safety factor again. The safety factor. The safety factor here, ISC for string, as I mentioned earlier, like the worst case scenario of irradiation. In that case, the short circuit current for string, and this is actually adjustable. That means 1.25 times short circuit current of the module. We actually got this data from the datasheet of the module. Now number three step, and in number three step, maximum parallel string. So how many parallel string can be implemented or installed for maximum efficiency or maximum performance? Indeed, number three, the maximum parallel string, maximum parallel string based on short circuit current limit. And the maximum parallel string, let's say n is defined the maximum number, so n, and if I write down here p, it's actually the subscript for parallel, and short circuit current is equals to the short circuit current of the maximum value over the safety factor 1.25 times the I short circuit current of module. This is actually theory, so not to worry. When I give you the brief explanation by using some real data, then you can understand precisely, not to worry. Anyways, so now it's time for step number four, where, so number four is the maximum parallel string. Again, we have to have this data as well. So maximum parallel string based on the DC input, the DC input current. Where we actually get this DC input? Of course, the solar PV panel, right? So based on the DC input current, number four, which is very important, where actually the important data here, the I module is equals to the module current at maximum power point. So the parallel string based on DC input current, that current is actually the module current at maximum power point. Now, number 5, the last but most important point, that is actually final safe number. I mean, the final point. Let's define this is actually the final safe number of parallel string. Parallel string. Indeed, the number in parallel is equals to the current, of course, the short circuit maximum current. This is actually the final equation. Maximum current over 1.25, the safety factor, times the current of short circuit of the module. We got this data from the module, and the actually this is the DC current, and the maximum DC current over 1.25 times maximum power point of the module current. This is actually the final equation. Now, if we have an example to calculate, say, example, short circuit current for module. Okay, so this is actually a data, a practical example, like this data for solar PV module data. Short circuit current is 13.2 and maximum power point each of the module data is 12.5, and the short circuit current for the inverter, that is actually 100 ampere, and the DC maximum current for the inverter is 80 ampere. So the number of PV module or number of PV uh, module in string, the parallel number, can be, the first equation is this one, and then second equation is this one. This is actually the DC current limit, and this is used for short circuit current limit. So let's use the first equation. Indeed, number of parallel for short circuit. So short circuit module, the test data for maximum short circuit current, that is 100 ampere from the inverter, and the short circuit current, of course, the safety factor also taken into account, and the short circuit current for the module, right? So which data we have to use? Of course, the 13.2. Indeed, we have 6.06, so we have to use 6 string for short circuit limit. And on the other hand, if it is a DC current limit, indeed, what we have to do, we have to do the DC maximum current is 80 ampere, so we have to use the 80 ampere, safety factor 1.25 times the maximum power point current of the module, that is 12.5. Let's plug in 12.5. So we have 5.12, or equivalent 5 string we have to use. So the final answer, we have to use 5 string. Thank you. So here is the another example. So in this example, the data of a solar module have a short circuit current is 6.2 ampere. Short circuit temperature coefficient is 0.065% per degree Celsius. Inverter to be connected has a maximum DC current is 23.6 ampere. The maximum cell temperature is 75 degrees Celsius. What is the maximum number of parallels thing we have to calculate, right? So current temperature coefficient, current temperature coefficient, coefficient uh, sigma short circuit is equals to 0.065% divided by 100 and the short circuit current, right? So the short circuit current is 6.2 and here is 0.065 over 100. So the current temperature coefficient is 0.00403 ampere per degree Celsius. Now the module short circuit current, module short circuit current, short circuit current at maximum operating temperature, maximum operating temperature ISC. What is the temperature? Operating temperature is 75 degrees Celsius. So 75 degrees Celsius is equals to the short circuit current at STC plus the temperature, current temperature coefficient short circuit, and the temperature difference is 75 degrees Celsius minus the STC temperature. Now plug in the value of short circuit current of that module at STC, that is 6.2 ampere, and the value of current temperature coefficient, that is 0.00403, and 75 minus the STC temperature, literally chosen 25 degrees Celsius. This data actually within the data sheet of the module. So after calculation, we find 6.4015 ampere. Now inverter maximum DC current, that is actually given in the question, or of course that is the maximum DC current for this, for the inverter is 23.6 ampere. So I inverter maximum current is equals to 23.6 ampere. Now it's time to calculate the maximum number, maximum number of parallel, maximum number of parallel string is equals to the inverter maximum current over the short circuit current of the module at 75 degrees Celsius. So what is the value for the inverter maximum current? That is actually 23.6, and the short circuit current at 75 degrees Celsius, that is actually 6.40. So let's plug in 6.4015. So here we have three number of string. By the boundary condition and the safety design, we have to use the three modules in parallel of a string. So this is actually the solution. So the final comment, the maximum number of parallelistic equation is this one. Let's change the color. Okay, so this is the main equation to calculate the maximum number of parallel string, the inverter maximum current over the short circuit current of a module if there is a temperature given. So indeed the temperature, I mean current temperature coefficient also need to be calculated. Indeed we have a value of this one, then plug in, we'll have the safety and the O scenario case of irradiation. We have to use the number of three parallel string for the better performance. Thank you.